Okay, notes for section 5.3 continued. We're going to look at the Pythagorean Theorem, which relates the three sides of a right triangle, and that's important. It only relates to a right triangle, meaning it has one angle that's 90 degrees. So if I have this triangle, that's a right triangle, again that's 90 degrees, that's important. If the sides are called A and B, and let's say C, this is the length of one of the sides, this is the length of the other side, and I have the C, which is actually known as the hypotenuse of the triangle. So C is always the one to pay attention to, because C is going to be the one that'll be across the 90-degree angle. So we need to know that A and B can be interchanged, they're just the two lengths, and C is always the longest side across the 90-degree angle. The formula that relates them is basically length squared for one leg plus the length squared for the other leg, and that equals C squared. So this is the length of the bottom leg, this is the length of the other leg of the triangle. A squared plus B squared is always equal to C squared, and always it has to be a 90-degree right triangle. Let's look at this example, which says find the unknown side of the triangle. So right off the bat we know that this must be our C because it's across the 90-degree angle. I can call this A and this B. It doesn't matter which one I call A, which I call B. So I relate them with the Pythagorean formula or theorem. A is this unknown length x, B is the one I already know about, 6 squared, and C I already know as well, it's just 10, so I put it in, that's 10 squared. It's going to give me x squared plus 36 equals 100. Now I need to go solve this quadratic equation. Remember, we isolate the x squared quantity, so I have x squared equals, looks like 64, and I take square root of both sides, and normally I would say x is plus or minus 8, but since I'm looking at an application and length of a triangle is always going to be a positive length, not a negative length, I will say x is equal to positive 8 because it comes from an application of a triangle where the length has to stay positive. Let's go look at part B. Again, it's a right triangle, and across from the 90-degree angle is the Z, so that must be my C. I'll call this guy A, this guy B. It doesn't matter again which one is A and which one is B. And I'll go use the Pythagorean formula. A is 12, plug it in. B we know this time as well is a 35. So 35 squared. And then C is the guy we don't know, so I'm going to call that the Z that they call it, and that's Z squared. So 12 squared is 144, plus punch that into your calculator. We get 1225 equals Z squared. That's going to give me, when I add them, 1369 equals Z squared. It already fits the form that I need, so I take square root of both sides. Z is plus or minus 37, punching that into my calculator and taking the square root. But again, since I'm talking about length, Z in this case is 37 units long. So it's a triangle of sides 12, 35, and hypotenuse 37. Okay, let's go look at part C again. Across from the right angle is the side that I'm going to call C, and then the other two guys I'm going to call A and B. So A squared plus B squared is equal to C squared. A is K, it's an unknown. B is also an unknown. Oh no, actually B is a 20, I know that one. So B is 20 squared. And then C, I have to be careful, is the quantity 3K, all of it squared. Now I go ahead and simplify things. K squared, leave it as is. 20 squared, punch it in, you get 400. And then 3K squared is really looking at two different terms. 3K times another 3K, because there's two of them. And if I multiply that through, 3 and 3 give me 9. K and K give me K squared. Now I go ahead and isolate the K squared quantity to make it look like one of these equations. So I'm going to move this K squared to the other side. That's 400 equals 8K squared. Divide by 8 and we get K squared equals 50. Now I'm ready to take square root of both sides. So K is plus or minus, looks like square root of 50. And again, I only need to use the 50, square root of 50, because I'm talking about a positive length. But that's just the k value. I have to go find, the direction said, find the unknown side of the triangle. So I have two things that are missing in my picture. I found k to be square root of 50. It didn't say approximate, so I won't. I'll just leave it as is. K is square root of 50. And then 3k, the other missing side, is really 3 times square root of 50. So that's, I guess, 3 square root of 50. And if I wanted to approximate, I could punch this into my calculator. And as an approximation, this would be approximately 7.1, and then this piece would be 7.1, then times the number 3, so approximately 21.2 something something is what I'm getting. And again, I'm just, whatever value I get for this one, I multiplied by 3 on my calculator to get this, so I don't have too much round-off error. So if it said give it an exact form, just leave it with the radicals in irrational form, square root of 50. If it said approximate, then you approximate and give a decimal approximation. For these problems, I'm supposed to explain why the equation is incorrect, an incorrect application of the Pythagorean theorem. So for the first one, it looks like it's length squared equals supposedly hypotenuse squared, but notice this is not 90 degrees. It's not a right triangle. So if it's not a right triangle, the Pythagorean theorem doesn't apply. That's why it's incorrect. This next one, number 30, seems to be a little bit more clear, because although this is the hypotenuse and the c value across the right angle, all they're doing is just adding the sides. And remember, they all need to be squared for the Pythagorean theorem to be applied correctly. So sides need to be squared. That's what's wrong with that one. Next one, I do see the squares, but I have to be careful because across the 90-degree angle is the c, which is x, and then these guys are my a and b. So it looks like they have them in the wrong places. This is the hypotenuse, these are the legs a and b, so it should really be 2 squared plus 11 squared for the b equals c squared. X needs to be on the other side of the equal sign, and the 11 doesn't need to be squared by itself. The x is going to be the hypotenuse squared by itself. So that's incorrect sides used in the a, b, and c values. Let's look at this guy. Let's see what's going on here. So I do have a right angle, that's the 25, which is my c. So I'm just going to call these guys my a and b. And if I use the Pythagorean formula correctly, I have to square the two legs. This one was squared, okay? Notice 16 needs to be 16 squared. They forgot to square it. And same thing on the right side. The hypotenuse 25 needs to be squared. So the squares were forgotten in some of the parts in number 32. The next 4 examples require us to solve a formula for the indicated variable like we did in the previous section. First one I've labeled number 1, a equals 4 pi r squared. I'm supposed to solve for r, so I have to get this r quantity alone all by itself. My focus is right here. And what is multiplied with the r on that same side is the 4 pi, so I just need to, since it's multiplied, I need to divide both sides by 4 pi, and then I have the r squared by itself. Now notice I have r squared by itself, but I need to have r to the first degree, so using the square root property, I can square root both sides, and that'll give me r equals plus or minus all this garbage, a divided by 4 pi. Now if the problem says that the radius has to be positive, greater than 0, remember, means positive. If it says the radius has to be positive, then I just toss out the negative value and say the radius is a length, a distance, it has to be positive, so I'm going to only keep the positive. If it doesn't say anything, then it might require you to leave both the positive and the negative. But for the purposes of this problem, just to make a note, if r is positive, if r is supposed to be greater than 0 or positive, only keep this answer but this is really what r is completely isolated to be, plus or minus the square root of that. Number 2, we have this formula, and we're supposed to solve for v, so I have my eye on the v squared part. Now notice there's a k attached to the v. I'm not going to worry about that yet because there's a 6 added on the same side. I'm going to move the 6 over first. Not like terms, so I leave them separate. Always move over the other garbage first and then take care of what's attached to it at the very end. Now this is times k, so I'm going to divide both sides by k, and I have v squared equals d minus 6 over k. Again, I have v squared. I want to knock down the power, so I'm going to square root both sides. So v is equal to plus or minus square root of d minus 6 all over k. And again, I didn't say anything about v being positive, so I'm just going to go ahead and keep both the positive and the negative. Next one, number 3, says f is equal to a half mv squared, and we're supposed to solve this guy for v, so I'm going to have my eye on the v squared part. And notice this problem has a fraction of a half. I kind of don't want to deal with that 1/2, so I'm going to multiply both sides by 2 over 1 or 2 to get rid of that fraction. Remember, if it's an equation and you don't like the fractions, you can eliminate them. And that only applies to equations. You can just multiply both sides by the LCD and get rid of them. So that's going to give me mv squared. Now there's no other garbage on this side for me to move to the other side like I did for the previous problem. I just have that m stuck to the v squared, so I'm going to use the inverse operation and get the v squared by itself. And I'm almost there. To knock down the power of the v squared and get it by itself, I'm going to square root both sides, and I have v equals plus or minus square root of 2f over m. And of course, if at any point they said v has to be positive or greater than 0, I would just give the positive radical and not both of them. Last one, let's see if we can fit it here. I have h equals 100 minus half gt squared. So it's going to be hard to see. Let's move it over a little bit. There we go. So I have definitely a fraction. I want to get rid of that. I have my eye on the t squared because ultimately I want the t to be by itself. I don't like that fraction, so I'm going to multiply each chunk by 2. This one so that the 2's can cancel, the next chunk, and everything on the other side of the equal sign as well. That's going to give me 2h equals 200 minus, these guys are now gone, gt squared. Now notice on the side of gt squared, there's this other garbage I have to deal with, so I'm going to subtract 200 from both sides, and I have negative gt squared equals 2h minus 200 because I can't combine like terms. Now still I have my eye on the t squared, and the g, or the negative g, is stuck to it, in other words multiplied by it. So I'm going to divide both sides by negative g, and that's going to get the t squared by itself. And that definitely looks kind of ugly. I have the t squared by itself, and I can go ahead and maybe square root both sides as is to get it alone. So one of the forms would be t is plus or minus this business over negative g. Or another version would be, if that negative g downstairs is bothering you, you can take that negative one upstairs and make this a negative 2h, and upstairs and make the next one a plus 200. So in a sense, you're taking the negative from downstairs and distributing it into both terms upstairs. And g itself could be a negative 5, for example, and once I plug in a negative 5 in here, the negatives can cancel and become a positive. So don't let that negative scare you.